In this video, we're going to explore isomers, what they are, and how we go about drawing them given a molecular formula. So first, what are isomers? In this course, we're only going to deal with structural isomers. Structural isomers are organic compounds with the same molecular formula, but different structural formula. So their atoms are arranged differently. So we're going to look at the different structural isomers of a single compound, C4H8. So C4H8 has the general formula CnH2n. And I'm not going to draw all of the structural isomers, but I will draw two. So one is but 1-ene, and another is cyclobutene. Cyclobutane. These two chemicals have very different properties, but the same molecular formula. The only thing that they have in common is they both have 1 unit of unsaturation compared to the straight chain alkane. So now we're going to look at how we go about drawing isomers if we're given a molecular formula. So for the formula C5H10, we're going to draw as many isomers as we can. And to do so, we have to figure out how many units of unsaturation are present. So a 5-carbon alkane should have 12 hydrogens. Here we have 10. So 12 hydrogens minus 10 hydrogens equals 2 hydrogens. This corresponds to 1 unit of unsaturation, and that's equivalent to either 1 double bond or 1 ring. So when we start drawing our isomers, we're going to always ensure that our isomers have one of those two features. So I'm going to start with a straight chain, and I'm going to draw my double bond on the first carbon. Naming isomers is really helpful in making sure that you don't repeat as you're drawing. So this is going to be pent 1-ene. Now I can take that double bond and I can just shift it to the next carbon. So in doing so, I create a new isomer, pent 2-ene. Now I could try to shift it one more time, but when I do so, I get pent 2-ene again. So this is where naming is important, because if you were to draw it and then name it, you would see it's the same. So that's all of my 5 carbon chains. So now I'm going to drop 1 carbon and make a methyl group. And again, just move my double bond down that chain. So this is going to be 2-methyl but 1-ene. I'm going to take that double bond and I'm going to migrate it down the chain again, and I will get 2-methyl but 2-ene. Okay, and then one last thing I can do is I can take that double bond back to where it was and move the methyl group 1 over. And so that's going to look like this. So I'm going to have my methyl group and my double bond split by 1 carbon. And this is going to be 3-methyl but 1-ene. So next up, I can't make any more 4 carbon chains, and 3 carbons won't work. If you're not sure, try some out. You'll always end up with 5 bonds to a carbon. I'm going to now move, so I've done all of my double bonds. I'm now going to look at rings. So first things first, I'm going to draw a 5-member ring, the simplest one I can come up with. Whoopsies. That's going to be called cyclopentane. Can't do anything else with that, so I'm going to go down to a 4-member ring with a methyl group. So that's going to be methyl cyclobutane. Can't really do much else with that, so down to a 3-member ring. And here I have some possibilities. So I can stick 2 methyl groups onto 1 carbon and get 1,1-dimethyl cyclopropane. I can take those carbons and split them up and get 1,2-dimethyl cyclopropane. Or I can put them on the same carbon as an ethyl group and get ethyl cyclopropane. So with 1 unit of unsaturation, we've managed to come up with 10 isomers. As you increase the chain length or increase the number of units of unsaturation, you're going to increase the number of isomers you can form. And so having a systematic approach is really helpful to these types of problems.